Welcome to EasyPeter channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the interconnection of two-port networks. That is, two networks are interconnected each other. Then, how to find out the two-port network parameters. That is, the two circuits are joined to each other. Then how to find Z parameters, Y parameters, ABCD parameters or H parameters. So that is the interconnection of two-port networks. For example, the given networks can be joined or can be interconnected in three forms. That is, the first type is cascade connection. That is, if the two networks are interconnected in cascade form, then how to find out? This cascade connection can be useful to find out transmission parameters. That is, ABCD parameters. If you want to find out ABCD parameters for two types of networks, then the two networks are joined in cascade connection. Then I will show you how to connect the two networks. For example, this is one network and this is second network. That is X and Y are two networks. Then according to two ports, the network consists of one port and two port on both sides. That is, this is plus minus V1, then passing current is I1. This is also plus minus the voltage is V2 on second port and passing current is I2. Similarly, the same format for second networks also. Then how to find out the cascade connection? That is, the second port is joined with first port of the second network. The second port will join with first port of the second network and also minus also. Then the complete second port is joined with the first port of the second network. Then this connection is called the cascade connection. This is called cascade connection. That is, the two networks are joined by side. Okay, that is interlinking each other. Then here also we find out the voltage V2 and here also we find out voltage V1 here. Then I am taking as I1 dash, suppose I2 dash, that is V2 dash and V1 dash for second network. Okay. In cascade connection, you have taken I1 dash equal to minus I2. So here the branch is series connection here. That is, this branch is the series connection. Nothing but both node points are joined each other. Same current is passing, but in reverse direction. That's why I1 dash equal to minus I2. Both are equal, but in reverse. That's why you can take it as negative value. Okay, this is the connection of cascade. Then what is the advantage of cascade connection? To find out ABCD parameters. That is, for X network, for first network, we know the ABCD parameters, that is A1, B1, C1 and D1 for first network after calculating, and also A2, B2, C2 and D2. These are the ABCD parameters of Y network and these are the ABCD parameters of X network. That is, you can calculate ABCD parameters for individual networks X and Y. Then for complete network, after joined in cascade connection, for complete network, how to find out the ABCD parameters after finding separate parameters. That is, the complete ABCD parameters of total interconnected two-port network is nothing but the multiplication of individual ABCD parameters of both networks. That is, A1, B1, C1, D1 into A2, B2, C2 and D2. That is the multiplication of individual ABCD parameters of two-port networks. Then you can get the complete interconnected network ABCD parameters. This is called the cascade connection. And what is second type connection? The second type connection is, that is, series connection. This series connection is also useful to find out Z parameters only. In series connection, we have to find out Z parameters of the two-port interconnected networks. Then, what is the series connection? That is, suppose this is network A, then we have one port and we have second port. Similarly, this is second network, we have one port and we have second port here. Then join here, the minus of the first port joined with plus, and the same second port also minus joined with plus. Then what is here? This is plus and this is minus, and on second port also this is plus, this is minus. It is taken as V1 and it is taken as V2. Okay, this is called the series connection of the two port networks, two networks. Okay, here I1 and here I2. Then what is here? Here also the current I1 is passing, on output side also the current I2 is passing. That means both networks input current is same I1 and output current is also same I2. So that is called the series connection. If the two networks are joined in series connection, then how to find out the Z parameters of the both a complete interconnected series networks? That is, if you find out Z parameters separately for, that is, Z11, Z12, Z21, Z22. This is for first network. That's why network X we are taking here. You can find out. Similarly, we will find out Z parameters for second network, that is Y network. Then the parameters is for Y here we take it. Then how to find out the, after finding separate Z parameters for both networks, then how to find out the complete Z parameters for series connected two networks, that is Z11, Z12, Z22. That means here the addition of Z11 of both networks. Similarly, same Z12 of X plus Z12 of Y. Similarly, Z21 X plus Z21 Y. Similarly, Z22 X plus Z22 Y. Okay, like that, after finding separate Z parameters for two networks in series connection, you can add the same corresponding path network. That is Z11 will be find out the adding of Z11 parameters of X network, Y network. Similarly, we have to find out Z12 parameter by addition of Z12 parameters of X network and Y network. Okay, like that, we have to find out the Z parameters of complete series interconnected two-port networks. Then the third one, The third one is nothing but here we are called as parallel connection. This parallel connection very useful to find out y parameters only. By using parallel connection network, we can find out y parameters. Then, what is the connection of parallel between two networks? So that is, this is called first network having plus minus one port and second port. Similarly, the second one is Y port, that is a Y network having one port and second port. So here, both positive ports are joined to each other and both negative ports are joined to each other. So what is parallel here? The networks will be connected between the same node points. That's why all plus are joined, all minus are joined. Okay, among there is on first port, on second port also. Okay, from joining, you can take as one node, that is plus, and second minus also taken as one node, that is minus. Here also one node minus plus, second node minus. Then at this here, you have to find out V1 and V2. Then the passing current is I1. Then the passing current is I2. Okay, this type of connection is called the parallel connection. In this parallel connection, we have to find out the y parameters. Suppose we have to find out y parameters separately for first network and second network, that is y11, y12, y21, y22 for network X, for example. Similarly, you have to find out y parameters for second network, that is for network Y. Then the elements you are taken as in terms of second network Y. Then how to find out the complete Y parameters of the parallel connected network? That means the adding of, suppose Y11, you find out, that is Y11 parameter of X and Y networks. Similarly, Y12 also, you have to find out adding of Y12 parameters of X and Y networks. Similarly, we have to find out Y21 parameters also, Y21X plus Y21Y. Then similarly, we have to find out Y22 parameter, that is adding of Y22 parameters of X and Y network. Okay. In this way, we have to find out the Y parameters for complete interconnected parallel two-port networks. Okay. Then, if you want to find out H parameters, that is you know the relationship between the two-port network parameters. By using relationship, you can find out the other parameters also. Okay, these are called the types of interconnected two-port networks. Then, by taking one simple example problem, then how to find out the complete two-port networks for interconnected system. That is, we have taken one example problem, that is find Z parameters. Find Z parameters for interconnected system. Okay, the circuit is resistance R and capacitance. The elements are joined in the form of a ladder network and inductor and capacitance also. That capacitance in parallel with a resistance. Then these are the second port. This is the first port and this is the second port. Here V1, consider passing current is I2. Here V2, consider the passing current from V2 is the I2. Okay. The values are here 2 ohm, 2 farad, 2 Henry, 1 farad, and 1 ohm. Okay. For this network, we have to find out the Z parameters. Then, first of all, after giving the circuit, you have to understand it is a cascade connection or series or parallel. Okay, this is the here we have to find out the not Z parameters. You have to find out ABCD parameters here. So this is the cascade network. That's why for cascade you have to find out ABCD parameters. Okay. Then first of all, you can divide the circuit into two parts. Okay. Here I am taking the first part is only R, C and L. This is the first part. Okay. Here consider V1 and passing current is I2. Here V2, the passing current from V2 is I2. Then here we know the circuit consists of RLC parameter. If the circuit having RLC parameter, how to change the given circuit? Okay, the circuit must be converted into a transformed network. What is the transformed network? That is, you have to apply Laplace transformation for the network. Then that can be converted network is called as the transformed network. Okay. For resistance, we have constant value that is 2. For capacitance, what is the Laplace here? 1 by S. That is 1 by Cs. Okay. The value is C value is 2. That's why we have 1 by 2 into S. For inductor, what is Laplace transform? S into L. That's why L value is 2, then S. That is 2 into S. Okay, this is the transformed converted network for the given circuit into Laplace transformation. Then here we have to find out the ABCD parameters of first network here. Then and we know here this current is I1 and second loop current is I2. Then similarly apply KVL for both loops here. For first loop apply KVL, that is V1 equal to current I1 is passing from both elements, that is 2 by 2 plus S into I1 plus 1 by 2S is the mutual element. Both currents are passing in same direction. That's why plus, then other drop with respect to I2 is 1 by 2S into I2. Then this is the first equation. Similarly, for second loop also, you have to find out, that is 1 by 2S into I1 other drop and 2S plus 1 by 2S. So both elements having in second loop, then the drop into I2. Okay, these are the KVL equations for both loops. You can simplify the equation, you will get the ABCD parameters. Therefore, that is from equation 2, the second equation, you have to find out the value of I1 here. That's why 1 by 2S I1 equal to V2 minus, take LCM, 4S square plus 1 by 2S into I2. Then multiply on both sides with 2S, then 2S into V2 minus 4S square plus 1 into I2. Okay, this is the standard equation for ABCD parameters, that is I1 equal to, that is I1 equal to C into V2 plus D into I2 here. From that, we know C value here, C into V2 minus D. Here, no, not plus, minus D into V2. From the, here this is the first network, that's why you consider C1 and D1. Then C1 value is 2S and D1 value is 4S square plus 1. That is, this is not plus here, this is minus, then that is the C1 value and D1 value. Similarly, you can find out A1 and B1 also. That is, we know I1 value, this I1 value you can replace in equation 1, that is in V1 equation, that is V1 equal to 2 plus 1 by 2S into I1 nothing but 2S into V2 minus 4S square plus 1 into I2. This is I1 value plus 1 by 2S into I2. You can simplify this equation here, that is 4S plus 1 by 2S, then 2S into V2 minus 4S plus 1, 4S square plus 1 by 2S into I2 plus 1 by 2S into I2. Okay, here 2S will be cancelled, then the equation will be transformed, that is, you can change, you can simplify. That equation is 4S plus 1 into V2 minus 8S square plus 2S plus 2 into I2. This is V1 equation. Even compare with standard value, that is A1 V2 minus B1 I2. Okay, this is the value of A1 4S plus 1 and this is the value of B1 8S square plus 2S plus 2. Okay, here we find out A1 B1 C1 D1 for first network. Then again, what is the second network? Then the second network is here. The capacitor in parallel with resistor. Okay, this is second network. That's why you have taken V1 dash and V2 dash and current also I1 dash I2 dash. Okay, here this network will be changed into transformed network. That is, you have to apply Laplace transformation. This value is 1 farad. That's why the value is 1 by S. This is 1 ohm. Then both are in parallel. That's why the single impedance value here, both values are in parallel. Then here same, that is V1 dash, V2 dash, I2 dash and I1 dash. The impedance value replacing here R1 R2 by R1 plus R2, then the value is 1 by S plus 1. That is a parallel combination of 1 and 1 by S. Then for this loop, you can apply KVL for two loops here. We have two loops for V1 and V2. Then the first loop equation is V1 dash equal to 1 by S plus 1 I1 dash plus 1 by S plus 2 I2 dash. That is 1 by S plus 1 into I1 dash plus I2 dash. Both currents are passing in same direction. That's why taken as I1 plus I2. Okay. Similarly, same for second loop also. we can obtain same equation. There is no change in the element. Only we have one single element that is mutual connected between both loops. That's why the KVL equations are two loops will be same here. That is V1 dash and V2 dash here. Okay. From first equation or from second equation also, any equation you can take now to simplify the equations. From that, we require I1 here. That's why you can find out I1 dash, that is V2 dash minus 1 by S plus 1 I2 dash. From that, I1 dash equal to S plus 1 V2 dash minus I2 dash. Okay, here compare with standard values, that is C2 V2 minus D2 I2. Okay, this is the for the second network. That's why we are taken as C2 and D2. That's why the value of C2 is S plus 1 and the value of D2 is minus 1 or 1. The equation in terms of minus, that's why the D2 value is 1. Similarly, you can replace I1 dash value in first loop equation. That's why you will get V1 dash equal to only V2 dash. Both are equal. That is A2 V2 dash minus B2 I2 dash. That means the value of A2 is 1 and the value of B2 is 0. There is no B2 term in the equation. That's why the value of B2 is 0. Therefore, the complete ABCD parameters of interconnected, that is cascade connected two networks, is nothing but how to find out cascade values, that is multiplication of ABCD parameters of individual network, that is A1, B1, C1, D1 into A2, B2, C2, D2. We know all values are found out already. Then you can replace that values here, that is A1 value is 4s plus 1 and A2 value is, that is B1 value 8s square plus 2s plus 2 and C1 is 2s and D1 is 4s square plus 1. This is the first ABCD parameters, and second ABCD parameter is 1, 0, s plus 1 and 1. Both are multiply each other. Then by matrix calculations, you have to multiply both values. Then you will get 8s cube plus 10s square 8s plus 3 and b value 8s square plus 2s plus 2 and c value 4s cube plus 4s square plus 3s plus 1 and d value 4s square plus 1. Okay, these are the ABCD parameters of complete cascade interconnected circuit or network. Okay, in this way, you have to find out the any two-port network parameters, either cascade, series, and parallel connection. Suppose here in this problem, we find out ABCD parameters, but we require H parameters. Then we know the relationship between the two-port network parameters. That is, by using that relationship, we have to find out the H parameters. That is, the H parameters in terms of ABCD parameters. Then, like by using that relationship, we can find out any parameters from two-port network parameters. That is, if you find out Z parameters, that Z you can find out ABCD also. If you find out Y parameters, By using the five parameters, we have to find out h parameters also. So like that, by using relationship between the two port network parameters, we have find out other parameters also. Please subscribe our channel and share to your friends.